Good day. Welcome back to Grower Academy Exam Prep. My name is Philip. I'm your mathematics teacher, and I'll be teaching you today on the laws of indices. And in today, we will understand what is the concept of indices, how to use it to simplify expressions, and also solve problems. Today's lesson objectives will be to know and understand the definition of index, understand the various laws of indices, and solving problems in indices. What is indices? The laws of indices provide us with rules for simplifying calculations or expressions involving powers of the same base. This means that the larger number or letter must be the same. For example, you have 2 to the power of 5 multiplied by 2 to the power of 3. 2 to the power of 5 here is the index, while 2 is the base number. Okay, so in that case, indices is mostly used with numbers that have the same base number as you see in this case. Okay, and there are several laws that guides that. We cannot use laws of indices to evaluate calculations when the bases are different. But when the bases are the same, then we can do that. For example, examples of calculations that have different bases is 2 to the power of 5 multiplied by 3 to the power of 3. In this case, we cannot use indices or the laws of indices to solve questions like this, but that is workable with the other example you see down below. Now, let's just move on. Now that we understand the definition of indices, let's move on to the laws of indices. There are 6 particular laws of indices. We have the multiplying indices, the dividing indices, the brackets with indices, the power of 0, negative indices, and fractional indices. Let's look at these laws of indices one after the other. 1. The multiplying indices. When multiplying indices with the same base, all you need to do is basically add the powers. And as you see here, you have a to the power of m multiplied by a to the power of n. Since a is the base number and it is identical, then all you need to do is simply add the index. And that gives you a to the power of m plus n. A quick example on that is if you're given an expression of a to the power of 3 multiplied by a to the power of 7. Since the base number are the same, I'll just pick a and then simply add the indices. And that gives me a to the power of 10. What happens if you have a coefficient attached to your base number? An example of that is 4 a to the power of 3 multiplied by 7 a to the power of 2. What do you do in this case? Simple. Let's focus on the base numbers and their respective indices. First, and the one we are done, we'll work around the coefficient. So first thing, there are just 2 steps here. First, you focus on the indices. And if we do that, we have the a to the power of 3 multiplying a to the power of 2. By the rule of multiplication, all you need to do is take one of the bases since they are identical and then add the indices together. And that gives you a to the power of 5. Now the second step is to now take the coefficients of each of these indices and multiply them by each other. So we have a 4 multiplied by 7, which gives you 28. And so finally, we just need to bring these two guys together, and we have our 28 a to the power of 5. Alright, so that is how to simply solve and understand the multiplying law of indices. The second one that we have is the dividing indices. If you have a base number to the power of m divided by a to the power of n, all you need to do when the base number are the same is take the base number and then subtract the indices, and then you have a to the power of m minus n. An example around that is if you have a to the power of 9 divided by a to the power of 2. Now you see that the base number are the same, which is a, and then all you need to do is pick one of the base number and do a subtraction of the indices. What you have now is a 9 minus 2, and then you have your base number raised to the power of 7. What do you do in a case where your indices also has a coefficient? So if you have a 21a to the power of 9 divided by 7a to the power of 2. Like the previous example, we just need to abide with 2 steps. First, focus on the index. And so if you have a to the power of 9 divided by a to the power of 2, by the rule of indices, the law of division, all you need to do is take one of the base numbers if they are equal or the same, and then do a subtraction of the index, which gives you a to the power of 7. Now the second step would be to focus on the coefficients on these indices. We have a 21 divided by 7, which gives you 3. So bringing these two together, we have a 3a to the power of 7 as our final answer. Third, let's go to the law of brackets with indices. And so this law is very simple. When you have a base number to the power of an index in a bracket to another index, what you basically need to do is just multiply the indices together. So if you have a to the power of m, all in the bracket of to a power of n, it becomes a to the power of m multiplied by n. A quick example of that is if you have a to the power of 3 and a bracket to the power of 4. What you have is just multiply the 3 by 4. So you take your base number a, and then you do a 3 multiplied by 4, which gives you a to the power of 12. Now the same thing will happen if you have a coefficient to a. If you have a coefficient, say for instance you have a 2a to the power of 3, all in the bracket to the power of 2. Now in this case you have to be careful. Your first step would be to focus again on the index number. So we have a to the power of 3 all raised to the power of 2, and you already know what to do. It becomes a to the power of 3 multiplied by 2, and that is a to the power of 6. But the second step is this. The coefficient is as well affected by the power outside the bracket. So you have a 2 now raised to the power of 2, and that gives you 4. Then the combination of these two gives you a 4a to the power of 6. Let's go to the fourth law. The fourth law is known as the power of 0. A non-zero value raised to the power of 0 is always equal to 1. And you find that there on the screen. A to the power of 0 will always equal 1. Okay? A quick example of that is if you have a 12 to the power of 0. A 12 to the power of 0 will give you 1. Again, say you have a 12 multiplied by a base number a raised to the power of 0. Since the index of a alone is 0, that gives you a 12 multiplied by 1. Since we know that a to the power of 0 is equal to 1. And so this gives us a 12 multiplied by 1, which is 12. Okay, so that is how simple. Now, it doesn't matter the number, it doesn't matter the base. If the base is even a million, raised to the power of 0, it still gives you 1. If it is a negative value, raised to the power of 0, it gives you 1. Alright, let's go to the fifth law. The fifth law is known as the negative indices. When the index is negative, put it over 1 and flip to make it positive. So whenever you see a base number to the power of a negative index, all you need to do is do what we call reciprocation. 1 over a to the power of m will be equal to a to the power of negative m. Let's do a quick example of that. If you have a 2 to the power of negative 3, this will give you 1 over 2 to the power of 3. And if you look at this, we've been able to successfully eradicate the negative value, the negative sign in our index. And if we do a further simplification of this, this is the same thing as 2 multiplied by itself in 3 places. And this gives us a 1 over 8. So 2 to the power of negative 3 ends up giving us a 1 over 8. If you want, you can rewrite 1 over 8 as 8 to the power of negative 1. You're still saying the same thing. Let's go to the 16. And this is a fractional index. When the index is a fraction, the denominator is the root of the number or letter, then all raised to the answer, all raised to the power of the numerator. So in this case, we have a x, a over b as a fractional index. The denominator is b, and a here is the numerator. Okay, so like I said, the denominator is the root of the number or letter. So I'm going to do the b root of x, the b root of x. So let me just erase that quickly. So the b root of x, and then I'm going to raise all that to the power of the numerator, which is a. A quick example of this again is going to be 9 2 over 3 as a fractional index. This 3 here is the denominator, so it's going to determine the root of 9. And so we're going to have a cube root of 9, all raised to the power of the denominator of the numerator, which is 2. So what is the cube root of 9? That is 2, all raised to the power of 2, which gives us a 4. Alright, so these are the basic illustration and explanation of the laws of indices. Let's go further to solve some exam style problems in the indices. Okay, and so I'm going to work on question 8. I expect you to do more the other ones on your own. So for question 8, I have 8b raised to the power of 2a multiplied by 4b raised to the power of 4a. Okay, so first thing you want to look at is first focus on the index number. So we have a b, so first step. So we have b to the power of 2a multiplying another b to the power of 4a. Okay, so what law do we use here? We just use the multiplying law. Okay, so by multiplication, we are simply going to add the index. So this becomes a b to the power of 2a plus 4a, and b to the power of 2a plus 4a, b plus 4a is equal to b to the power of 6a. Now, the second step to focus on will now be the coefficient of these base numbers. which is 8 multiplied by 4, and that gives us a 32. So final step is just to bring both of them together, right? And if we do that, we have a 32 with an index of b to the power of 6a. So our final answer is going to be a 32 to the power of b, or up to a 32 multiplied by b to the power of 6a. Okay, so that is how to solve that. And we also have several examples on dividing rules, several other examples on the bracket rule, and that will be the end of today's class. We will, for more videos, please follow us on YouTube at Grow Academy. Thank you, and have a nice day.